Hi everyone, I am Dr. Prajwith Rai. Today we are going to discuss about a primary hemostasis. Now, whenever there is a vessel damage, it will lead to hemostasis. There will be a hemostasis which is responsible for the stopping of bleeding. Now, what are the steps involved in this? The first step is a vasoconstriction. The vessels will become smaller in size. Then there will be primary hemostasis, that is nothing but the platelets will come and aggregate here. Now, this platelet aggregation will be sealed off by this fibrin clot, which is called as secondary hemostasis. So today we will be discussing about the primary hemostasis. Now, whenever the vessel gets damaged, its endothelium will be disturbed and it will get destroyed, and the von Willebrand factors which are present within this endothelium will be released, and the collagen fibers will be exposed in the surface of this blood vessel. Now, along with this, the sudden reaction for this damage will be a vasoconstriction. So the collagen is exposed, the vasoconstriction is happened, and there are these von Willebrand factors. The von Willebrand factors will have very high affinity towards this collagen fibers which are exposed, so they will go and bind to this. Now, this von Willebrand factors will the receptors for this von Willebrand factors will be present in the platelets called as GP1B receptors. This GP1B receptors on the platelets will come and attach to this von Willebrand factor. Now, when this happens, the platelet is activated. So, whenever the platelet is activated, its size increases so that the surface area increases. It starts expressing the fibrinogen receptors. Now, this receptor is nothing but GP2B/3A receptor. Now, this receptor is a fibrinogen receptor which will be expressed. Along with this, two granules will be released by these platelets. These are nothing but alpha granules and the dense granules. Now, the alpha granule will release again more of the von Willebrand factor, leading to more activation of platelets. Also, the von Willebrand factors will the alpha granules will release the platelet derived growth factor, which will help in the long term healing of the wound. Now, similarly, the dense granule will release two things, that is ADP, adenosine diphosphate, and thromboxane A2. Now, these both again will help in the platelet aggregation. So, von Willebrand factor, ADP, thromboxane A2, everything will help in the platelet aggregation, and platelet derived growth factor will help in the long term healing. So, as I told, the alpha granule will release the von Willebrand factor and the platelet derived growth factor, whereas the dense granule will release the ADP and thromboxane. Now, what happens to this von Willebrand factor? The von Willebrand factor again goes and binds to the collagen, and it will start aggregating more platelets, and also it will bind to the platelets GP1B receptor and it will activate more platelets. Now, what happens to the platelet derived growth factor? It will be there in the local area and it will help in the long term wound healing. Now, what happens to the ADP and what happens to the thromboxane? Now, both of these will have receptors in the platelets. Now, the platelet has a receptor called as P2Y12 receptor. P2Y12 receptor is present on the platelets, for which the ADP goes and binds. Now, similarly, there is a receptor called as TP receptors in the platelets, for which the thromboxane will go and bind, and this will lead to again activation of protein. The surface area increases. It starts expressing GP2B3A receptor, that is nothing but the receptor for the fibrinogen. So these are the GP2B3A receptors, which are the receptors for the fibrinogen, which is expressed by these activated platelets. So whenever platelet is activated, the fibrinogen receptors are expressed. Now, the fibrinogen that is circulating in the blood will come and bind to this fibrinogen receptor, and this will lead to aggregation of platelets. So this will continue and multiple platelets and fibrinogen comes and aggregates in the area of platelet activation, that is in the area of vessel injury. Now because platelets are rich in actin, the actin and myosin are the products which is responsible for the muscle contraction. The similar actin is present in these platelets, so which will lead to contraction of this platelet, so leading to the primary hemostatic plug. Now this is a temporary hemostatic plug, or this is why it's called primary hemostasis. Now this should be sealed off by a web which is formed by the fibrins. Now this fibrin, the fibrinogen should be broken down into fibrin to make this fibrin mesh, which will happen in the secondary hemostasis that we'll discuss in the later classes. So this is how a primary hemostasis happens. So in summary, whenever there is a vessel damage, the endothelial cells will secrete von Willebrand factor. Now this will bind to the GP1B receptors which are present on the platelet, leading to activation of platelets. Now, whenever platelet is activated, the surface area increases. It will express the fibrinogen receptor GP2B3A receptor, which will lead to binding to the fibrinogen and platelet aggregation. Along with that, it will release alpha granules and the dense granules. Now the alpha granules release the platelet derived growth factor, which is responsible for long-term wound healing. Along with that, it also releases von Willebrand factor. Along the dense granules will release ADP and thromboxane, and all of this will help in the further platelet aggregation. Once a platelet is aggregated, it will attach to each other with the help of fibrinogen and its receptor GP2B3A, and it will form a primary hemostatic plug which will contract at the end because of the actin. So this is how a primary hemostasis happens. Very simple concept. Thank you everyone.